In Java, there are just so many ways to store your data. But what if there was one single key that could unlock all of them? Well, today, that's exactly what we're going to talk about. Java's universal key for collections, the iterator. Okay, so here's the real problem we're up against. You've got data in lists, you've got it in sets, and who knows what else. How on earth do you write just one piece of code that can gracefully walk through any of them without a ton of if-else statements? I mean, think about it. You've got lists that are all about their index numbers. Then you've got sets, which have no indexes at all. And maps, they've got their own key value thing going on. Each one plays by a completely different set of rules. So yeah, a loop you write for a list is going to totally fall apart if you try to use it on a set. Now, don't get me wrong, the Java Collections framework is incredibly powerful. But all this variety, it can be a real headache. We desperately need one single consistent way to get to our elements, so we're not stuck writing a special loop for every single data structure out there. And that, my friends, is exactly where the iterator comes into play. By the time we're done here, you're going to see how this one tool acts like that universal key we've been talking about, a super clean way to access elements in pretty much any Java collection you can throw at it. All right, let's really dig into the problem we're trying to solve here. I mean, why can't we just use the good old-fashioned loops we already know and love? What's the big deal? So, the classic for loop, right? That's probably the first thing that pops into your head. You know the drill. You set up your counter I, you loop from 0 up to the list size, and you just use list.getI to grab each element. It's simple, it's predictable, and it works great. But there's a catch. It's got this one little hidden dependency. And that dependency, it's the index. The second you try to run that same loop on something like a hash set, which couldn't care less about indexes, your code just breaks. Kaput. You can't call .getI on it. All of a sudden, our supposedly simple key only fits one specific lock. We've totally hit a wall. Okay, but this is where our hero finally makes its appearance. To solve this whole mess of different collection types, Java gives us this amazing universal tool, the iterator. The best way to think of an iterator is like a guide or a middleman. It knows all the secret handshakes to talk to the collection, but it just gives you a really simple, standard set of controls. You don't have to care if it's an array list or a tree set or whatever. You just turn to your guide and say, hey, what's next? And you don't even have to build this thing from scratch. You just go straight to the collection itself and ask for one. You call its .iterator method, and the collection basically hands you a custom-made key, one that's perfectly designed to unlock its own elements, one at a time. Okay, so we've got our key. Now what? How do we actually use it to open the door and see what's inside? Let's break down the mechanics, because it's super simple. The pattern is honestly beautiful in its simplicity, and it's always the same. It's a two-step dance. First, you ask the iterator, hey, is there anything else in there, using hasNext. If it says yep, then you say, awesome, give it to me, using next. You just repeat that little check then get process over and over until you've gone through everything. And notice how these two methods have totally separate jobs. hasNext is just asking a question. It's like peeking through the keyhole. It doesn't change anything. But next, that's the action. That's what actually gets you the element and moves you to the next position. It's a simple rule. Always ask before you take. Okay, now we're getting to the really cool part. This is where iterators go from just being useful to being absolutely essential. Sure, walking through a collection is great, but what about the much trickier problem? How do you safely change a collection while you're still in the middle of looping over it? This is such a classic trap for developers. You're looping through a list, you spot an element you need to ditch, and now what? What do you do? Because your first instinct, it might just be the completely wrong one. Yeah, this chart pretty much says it all. If you try to call list.remove right from inside your loop, you're basically inviting chaos to the party. It's like pulling a link out of a moving chain. You might end up skipping elements, or worse, your whole program could just crash. But using the iterator's own remove method, that's like carefully and safely unlinking that piece. Seriously, it is the only safe way to do this. See, the iterator's remove method is really smart. It knows exactly which element you just looked at with next, and it works together with the collection behind the scenes to remove it properly without messing up your loop state. So what actually happens if you ignore all this and use that dangerous direct list.remove method anyway? Well, Java doesn't just shrug and let you create a mess. It has a built-in defense mechanism, and it's called failfast.
the moment you try to modify a collection directly while an iterator is busy walking through it, bam, Java throws this exception. It just stops everything right then and there. And the name is perfect, right? It detects a concurrent modification, two things happening at once, and it fails fast, instead of just letting your program limp along with potentially corrupted data.
And here's the clever bit behind how it works. Just imagine the collection has this internal counter, a mod count. Let's say it's at 5. When you get an iterator, your iterator also takes a little snapshot and remembers that number, 5. Now, if you go behind its back and modify the collection directly, the collection's counter bumps up to 6. The very next time your iterator tries to do anything, it checks the numbers. It sees it's 5 doesn't match the collection's 6, and it immediately throws that exception. But when you use the iterator's own remove method, it's smart enough to update both counters at the same time, so they always stay perfectly in sync.
So let's pull all of this together. Why does this all matter so much? Why is this design so important? Well, it really comes down to a fundamental principle in good software engineering. This quote really just nails it. The iterator's whole job is to separate the act of traversing from the actual structure you're traversing. It builds this beautiful bridge so that your code doesn't have to get its hands dirty with the messy internal details of the collection. And that, right there, is an incredibly powerful idea. So what are the big 3 takeaways here? First, you've got universality. It's that one key that works on pretty much any collection. Second, safety. It is the one and only approved way to modify a collection while you're iterating over it. And third, abstraction. It lets you hide all the complex details, keeping your own code clean, simple, and focused. So you see, the iterator is so much more than just a fancy loop. It's a really powerful design pattern that helps you write code that's both robust and incredibly flexible. You now have the universal key. The only question left is, what amazing data-agnostic code are you going to write with it?